Recall the first relationship that we established was d1 plus d2 equal to a. So we're going to now use our expressions for d1 and d2 to say that, well, the root of c plus x squared plus y squared plus root of c minus x squared plus y squared is equal to 2a. Well, we can subtract that second term from both sides of the equation to get c the root of c minus x squared, or c plus x squared, my mistake, plus y squared is equal to c 2e minus the root of c minus x squared plus y squared. We can square both sides to get c plus x squared plus y squared is equal to, let's say, 4a squared, let's say minus 4a root c minus x squared plus y squared plus c minus x squared plus y squared. We can expand these brackets, so we'll get c squared minus 2cx, or rather plus, I keep putting a minus here, plus 2cx plus x squared plus y squared equal 4a squared minus 4a root c minus x squared plus y squared. Second bracket, we get c squared, this time minus 2cx plus x squared plus y squared. We can, well, we will get a couple zeros here. So this guy gives us a nice big 0. This guy gives us a nice big 0. This guy also gives us a nice 0. So you could write that as, let's say, 2cx equal 4a squared minus 4a root c minus x squared plus y squared minus 2cx. If we go ahead and add 2cx to both sides, we get 4cx is equal to 4a squared minus 4a root c minus x squared plus y squared. We can divide throughout by 4 to get cx is equal to a squared minus e root c minus x squared plus y squared. We can subtract cx from both sides and add a root c minus x squared plus y squared to both sides, where we'll be left with a root c minus x squared plus y squared is equal to a squared minus cx squared, or rather cx. Oof. If we go ahead and square both sides, we're left with a squared by c minus x squared plus y squared. On the right hand side, we're left with a4 minus 2a squared cx plus c squared x squared. We can expand that bracket to get a squared into c squared minus 2cx plus x squared plus y squared equal e4 minus 2a squared cx plus c squared x squared. We can expand that bracket to get c squared minus 2a squared cx plus x squared plus e squared x squared plus e squared y squared is equal to a4 minus 2a squared cx plus c squared x squared. Get one more 0 here, where, well, this guy gives us another 0. We are left with a squared c squared plus e squared x squared plus e squared y squared equal e4 plus c squared x squared. We can go ahead and subtract e squared x squared from both sides and c squared x squared from both sides, or rather, no, that's my mistake. We could subtract e squared c squared from both sides and c squared x squared from both sides. So we're left with, let's say, e squared x squared, let's say, minus c squared x squared plus e squared y squared. And on the right hand side, we're left with e4 minus e squared c squared. If we factorize x squared from the first two terms on the left hand side, we'll get c x squared into e squared minus c squared plus e squared y squared. We can factorize e squared from the two terms on the right hand side to get e squared into c e squared minus c squared. We can then divide throughout by this guy. So if we divide each term in the equation by e squared into e squared minus c squared, well, on the right hand side, we're left with a nice 1. On the left hand side, well, we'll be left with x squared on e squared, and, well, plus y squared on e squared minus c squared. And, well, we're basically there. So we just have 3 substitutions to make, where we established earlier on that, well, we let big X be equal to x minus h and big Y be equal to y minus k, and this guy. So this guy right here, b squared is equal to e squared minus c squared. So if you make those 3 substitutions, substitute e squared minus b squared for e squared minus c squared, sorry, for b squared, and substitute big X for x minus h, big Y for y minus k, we are there. So we get, well, x minus h squared on e squared plus y minus k squared on, well, we just saw that this guy's denominator here is b squared equal 1. That's our equation.